Today we are discussing about the topic friction. What do you mean by friction? Here this is your definition. When two surfaces are in contact with each other and one surface tends to move with respect to the other, a tangential force will be developed at the contact surface in the opposite direction of motion. This tangential force is called as frictional force or friction. Here, one object is there, that weight is W, that is indicated in your diagram. What is your Newton's third law? For every action, there is one equal and opposite reaction. Here, one weight is there, that weight is applied on one rough surface. So, one weight is there, again one opposite reaction, that is normal reaction is there, that is indicated as NR. Then one external force, pull force is there, that is indicated as P, and one F is there, that is one frictional force. Here P is one external force, that means applied force, and F is one frictional force. Then NR is one normal reaction, and the W is one, capital W is one weight of the object. Then go to the definition. When two surfaces are in contact with each other, here two surfaces means one weight is there and one rough surface is there, and one surface tends to move with respect to the other. That means one force is there, one external force is there. Because of this force, that means P, it tends to move with respect to the other. A tangential force will be developed at the contact surface, that means in between the rough surface and the object there is one what tangential force will be developed. What's the direction here? In the opposite direction of the motion. That tangential force is known as one frictional force, otherwise friction. Next, we are discussing about types of friction. Before that, again, one topic is there, some advantages and some disadvantages having frictional force. Frictional force having some advantages and some disadvantages. What are the advantages here? For example, friction enables us to walk or ride a vehicle. If the friction force on the floor or road surface is absent, then it would not be possible to walk or ride a vehicle. Again, one more thing, to transmit power from a motor to a machine, one belt is used. These belts are working with the frictional force at the contact surface. Then what is the disadvantage here? The disadvantages is it increases the wear and tear of the machine, which leads loss of energy and loss of power. Then types of friction. What are the types of friction here? Two classifications are there: dry friction, otherwise known as Coulomb friction. Second one is fluid friction. Dry friction is classified as static friction and dynamic friction, and again dynamic friction is classified as sliding and rolling friction. Then what is dry friction? Dry friction refers to the friction which develops in between two dry surfaces, slides or tends to slide relative to another. Here, what is the surface means? Surface property means two dry surfaces. In between these two dry surfaces, the friction is one. What is the friction here? Dry friction. Then this is two type: static friction, and the second one is one dynamic or kinetic friction. Then first one, static friction. What is static friction means? Friction experienced by a body during rest. At that time, one frictional force is there, that is known as one static friction. Then what is dynamic friction? Friction experienced by a body during motion, that is one dynamic friction. Then two types of dynamic frictions are there. First one is sliding and second one is rolling. As the name implies, what is sliding friction is the friction experienced by a body when it slides over an another. That means another object or another surface. Then second one is one rolling friction. That is one friction experienced by a body when it rolls over a surface. That is known as one rolling friction. Then what is limiting friction? The next topic is limiting friction. What is limiting friction? Listen, consider a body resting on a rough horizontal surface as shown in diagram. Suppose if the body weight is W, the body is pushed by a force capital P, still maintaining the contact between the rubbing surface of the block and the floor, then the roughness of the rubbing surface will oppose the motion. That means one force is there P, then again one force, that means F is there, that is on the which direction? Here what is the direction of F here? That is one leftwise direction, that means negative x direction, and the P is positive x direction, that means P is pushing force. The opposing force, that means frictional force, is one F, that is on the opposite direction. The resistance developed due to the roughness of the body is called a frictional force, or simply we can say friction. Is it? Yes. Then the friction force is independent of the area of the contact but dependent on the degree of the roughness between these two bodies. That means in between one resistant force is there. That means one surface and one body, rough surface and body. There is one resistant force is there. The maximum resistance offered by the body is called limiting friction. Okay, the maximum resistance offered by the body is called limiting friction, and it is denoted as capital F suffix M. Then next one is one coefficient of friction, that is denoted as mu. The definition is one the ratio of limiting friction to the normal reaction, that is known as one coefficient of friction. Mu is equal to, simply we can say, limiting friction divided by normal reaction, that is limiting friction is denoted as F suffix M divided by normal reaction is one N suffix R. Then next one is angle of friction. Angle of friction is phi, denoted as phi. Check the diagram. This diagram shows a body of weight W, capital W, placed on a rough horizontal surface and subjected to a horizontal push, capital P. That is what direction? Direction is what? Positive x direction. When the force exceeds the limiting friction, the body starts moving. That means when P is high when compared to F, the body will starts to move. There are two reaction components, Fm acting in the opposite direction of P and normal reaction Nr. Here there are two reaction components, Fm and Nr. The next topic is one angle of friction. Angle of friction. These two reactive forces can be combined to a single resultant, we can say capital R. The equation is what? R is equal to root of Nr square plus Fm square. That is Nr is what? Normal reaction and Fm is what? Limiting friction. That is what is the equation is resultant R is equal to root of Nr square plus Fm the whole square. Then see the diagram, second diagram, the angle between the resultant, you can see the diagram, second diagram, the angle between the resultant capital R and the normal reaction. You can see one line is there R and next one is NR. In between one angle is there, that is known as one angle of friction. Then some important formulas are there. coefficient of friction mu and angle of friction. Here tan phi is equal to, already we studied, phi is equal to, tan phi is equal to Fm divided by Nr. Then mu is equal to tan phi, and Fm is equal to, that means limiting friction is equal to mu into Nr. That is what mu is equal to coefficient of friction and Nr means normal reaction. Then next topic is what? Coulomb's law of dry friction. Here Professor Coulomb has presented some laws of friction based on his research, which are grouped as two groups. Then first one is laws of static friction, second one is laws of dynamic, otherwise kinetic friction. What are the assumptions here he made us? First one is the frictional force always acts in the opposite direction to that the body tends to move. That is our first point. Then second one, the frictional force does not depend on the shape and area of contact of the bodies. Already these 2 points already we discussed in the earlier session. Then the frictional force, third one is frictional force depends on the degree of roughness of the contact area between two bodies. Then the fourth one is what? The frictional force is equal to the force applied to the body so long as the body is at rest. Then fifth one, the limiting frictional force, already we studied this one. The limiting frictional force Fm bears to constant ratio to the normal reaction. That means one equation is there, Fm is directly proportional to normal reaction. Then we can multiply one constant mu s, that is the equation is one, Fm is equal to mu s into Nr. That is your equation. Then next one is what? Laws of dynamic friction. It says first point is the frictional force always acts in the opposite direction to that the body moves. Second one, the magnitude of the dynamic friction bears a constant ratio to the normal reaction between two surfaces. And the third one is coefficient of kinetic friction is less than the coefficient of static friction. These are the laws of dynamic friction statements. Then the next one is one, impending motion. What is impending motion is the state of motion of a body which is just about to move or slide is called what? Impending motion. Here what is impending motion is the state of motion of a body which is just about to move or slide. That is what? Impending motion. When the maximum frictional force is attained and if the applied force exceeds the limiting friction, listen, when the maximum frictional force is attained and if the applied force exceeds the limiting friction, the body starts sliding or rolling. Is it okay? That is what? That is what? Impending motion. Once again, the state of motion of a body which is just about to move or slide is called what? Impending motion. Then what is the condition here? When the maximum frictional force is attained and if the applied force exceed the limiting friction, underline that word, exceed the limiting friction, the body starts sliding or rolling. That is what? Impending motion. Then some basic concepts are there. Check the diagram. First diagram. Here F is equal to 0 because we have no forces, external force here. One force W is there. What is W? W is the weight of the body. And what is Nr? That is normal reaction. Here there is no external force. So there is no what? There is no motion. There is no force. That means F is equal to 0. So listen, block of weight W placed on the smooth horizontal surface. The body is in the condition of equilibrium. What is the condition here? You have to study the condition here. Summation of V is equal to 0. Then Nr is equal to W. That means Nr is equal to W. There is no force. Then second one. Here one P is there. What is P? External pull. Here block of the weight is W placed on a rough horizontal surface and pushed by a inclined force. underline that one, inclined force capital P at an angle theta. You can see this in your diagram. The horizontal component of the force capital P, that is for every inclined force, for every inclined force, here P means it have one horizontal component and one vertical component. In our case, the horizontal component of the force P cos theta, that means horizontal component is one P cos theta, tends to move the body towards left, isn't? Because the P is, what is the direction of P here? Towards left. So the body tends to move is one, which direction? Towards left. But this motion is prevented by the frictional force, isn't? F is there, frictional force capital F developed in the opposite direction. Is it okay? Then when the developed friction force capital F is less than the limiting friction, the body still remains in the condition of equilibrium. Hence, the equation of equilibrium can be applied to solve. Here the condition is one, summation of H and summation of V also 0. Here if one component is there, what is the component here? Horizontal component is there, F is equal to P cos theta, and second one, summation of V is equal to 0. There, that means one, here there is no vertical forces here. So just we are coming to one assumption, summation of V is equal to 0. So NR is equal to the total one is one W, weight is there, plus one vertical component P sin theta. Then next case is one, here F is equal to Fm, that means limiting friction is equal to F. That is your next condition. Here summation of H is equal to 0 and summation of V is equal to 0. Here only one component is there. For the first one, Fm is equal to P cos theta, and the second one, NR, normal reaction, is equal to weight plus P sin theta. Then the last one is one, F is greater than Fm. Here, if the horizontal component of the force capital P, that means horizontal component is one P cos theta, exceeds the limiting friction, that means Fm, then the body will be in motion. The body is not on the condition of the equilibrium. So here Fm is equal to mu into N, cannot be applied. Okay, thank you.